Hello there, Joe Shaw, Single Engineer Group for APM. This is my weekly update video, slightly delayed, but better late than never. At the moment, we're starting to put issues together for the videos themselves. This is, that you can see now, is the APM issue for this week. I'll have to record again at some point. So here's my current update. I'll sort my headphones out. That's better. I showed you the Datadog agent Sandbox a bit last week. That's come along quite a long way, that project. This allows us to test that agent in isolation. We've added some stuff to isolate the network there. It's in Docker Compose, and add core DNS so we can capture any external traffic. So in that respect, we can see if the agent is sending any outbound requests that we wouldn't normally know about, because while we can see the expected requests through the mock servers that we previously set up, we can't be sure without auditing all the code in depth that there aren't other requests going on. So I'll show you what I mean by that. So we've got the Datadog agent there in this compose file. You should be able to see this better than usual now because I've actually got it zoomed in, whereas before I didn't, I noticed. And at the top of this, you can see we've got a DNS proxy set up here using core DNS, and this is using that DNS proxy IP. So if I actually go into this and have a look at the logs in the DNS proxy, and in fact, let's rep Datadog in there to see if there's any requests going through there. What you'll see, and the only other request that's not now being captured by this compose environment and going to one of our services, are Datadog requests here for NTP, Network Time Protocol servers, which is a good idea and to be expected. So it keeps the agent in synchronization. So even if the host machine has the wrong time settings, it can reach out and grab some NTP settings and synchronize with those servers. So that's fine. I don't think we need to worry about that going through there. What we've got next. Yes, so we've added into this environment a ClickHouse data store with a Golang service that sits on top of that to capture the series data. It's a really simple setup. I'll show you this. The series Go agent here, it's just in one Golang file. And you'll see that ClickHouse has a very much a sort of SQL-like dialect. In most cases, it's almost identical. We create a metrics database on startup here and a series table in that database. And it's really just a sort of flattened representation of the series data we get from Datadog. Not much thought has gone into this. And it's something that we will redesign and do some benchmarks against to get a better data model in place, because this is completely normalized and it's not a very efficient way of doing it. So you've got timestamp, host, metric value, and an array of tags there. And we're using this merge tree engine, which is the default engine in ClickHouse, which I need to spend some more time looking into. We don't bother with a primary key, and we're just ordering it. All the records are there by timestamp. So that will create a timestamp index in there. And this is some code to flatten the incoming requests and store them. And you can see we've got very similar sort of familiar SQL-like code here, where I'm creating a transaction, a statement, and writing them all in. And I've also got Grafana sat on top of that, pointing to that ClickHouse data source. Quickly show you that. So here's Grafana sat there. What you get with the ClickHouse data source, which isn't built in, you have to add this plugin in. You get, close that, a simple way of setting it up it will try and detect timestamp column that it will want to sort by. And you don't get much in the way of query editing capability, but it gives you some sort of template variables that do some automatic expansion, like this time filter here. So if we look at the actual query, the time filter is actually converting epoch times to dates and checking that the timestamp is within those. And here what we're doing is filtering this data down to the system disk write time percentage here. So we just refresh this. I've noticed with this plugin, the auto refresh doesn't seem to be working. So look in the last 5 minutes. So let's see if we can actually run a stress ng test here. We'll kick that off for 30 seconds. So I'm just going to run a hard drive test with 32 workers. And it's just doing sort of IO sync, buffer syncs to disk. And hopefully this will get some changes in those disk metrics. It's always a bit of an issue when you're doing these sort of disk things, when you've got a lot of RAM. Often things just get memory mapped and you don't see any changes to the disk. So we can just wait for that. I've just set that for 30 seconds and there it is. You can see it's done some operations there. If we have a look at this, you can see a big spike there. So relatively, if we look at that time frame there, they were sort of normal percentages. And then if we look at the last 5 minutes, you can see that big spike. Now, what I don't really understand in this data is why that is supposed to be a percentage, but it's higher than 2000. I don't know why that is. Something I need to look into. It's something to do with the Datadog agent. I'm not quite sure why. But you can see that big right spike there. And it's coming back down there. And there we go. And it's roughly, what is it, 2:20:36. Yeah, so like roughly over 30 seconds to a minute there. So you can see that's working fine. And if we took that spike off, you can see the normal data set there. In terms of the query there, we are grouping by host and tags there. So I've concatenated the tags together. So you can see for this data set, we've got my host name and we've got device names for the individual disk devices here. And you can see the only ones getting hit are the real disk devices here. And there's lots of loop logical volumes here that aren't doing anything at all. If you look along the bottom there. Right, so that's that. So there's Grafana configured, yeah. We did notice that there's no Docker stats being collected other than some basic ones. I'm hoping this is just a C groups v2 issue, and otherwise it would work. I need to test the agent out in Kubernetes really just to make sure that it is really getting all the metrics that I would expect. It does seem to be getting all the system metrics that I would expect, as you would think it would. This is the Datadog agent. We can have fairly high confidence that it's doing what we expect. Yes, and yeah, configuring the agent, because it's kind of set up with lots of different endpoints. If you want to configure everything like process, logs, the APM stuff, AppSec stuff, you would expect these are environment variable overrides. You would expect some level of consistency there, but there are some inconsistent bits like the logs URL not allowing you to specify a protocol in the actual URL and having that set somewhere else, things like that. Also, certain things that aren't consistent in terms of the sort of schema that you would expect. These are documented, but it just makes setting this up a bit more awkward. We might be able to solve that by providing our own image, for instance. Some items of interest that came up. There's an article here about talking about observability as a braid of data instead of the classic 3 pillars. So you're weaving them together with contexts that are coming from that trace information. This is something that a lot of products are starting to offer now, and it's something that we'll definitely look to provide in the future. And also, one thing that keeps coming up is people asking, why aren't we using the open telemetry collector? Because it is becoming the sort of I wouldn't say the standard, but it's getting a lot of traction. There are a lot of blogs about it. What I would say is the OpenTelemetry collector does have a Datadog exporter. So in theory, as long as we keep the data modeling ClickHouse or whatever time series database we use generic enough, it won't matter, because this format, this exporter would still work. You could still use OpenTelemetry. You don't need a Datadog agent installed. So that would be great. So up next, I need to dig further into ClickHouse here. So we've started doing that, looking at some logs, looking at some of the sort of drivers, and there's the time series database benchmarking tool there that we'll look at a bit further. And what I want to do early next week as well is create an APM architectural design to share in GitLab, so that we can get some early feedback on that and start to look at setting up infrastructure and just general sort of design assumptions and things like that. Okay, and that's it for now. Thank you for watching. I'll see you next week.